it is said that the two processes can communicate in a client server relationship. So we can say that our one system is working as a client while the another system is working as a server, and both can communicate with each other. Okay. The second thing about the transport layer is addressing. The type of address that we are going to be used on the transport layer, it is known as the port address, or we can say the port number. So when we are talking about the delivery at the transport layer, we need to define the four things, that is the local host, local process, remote host, and remote process. So we can say that here this client is local host and process on this client is, we can say, the local process. Okay. Same way, this one is the remote host and the process on this remote host can be known as the remote process. Okay. So if you want to assign something, okay, so we know that for this client and server, we are using the IP address. To identify this local host and remote host, we are using the IP address. But to identify the particular process on the client and the particular process on the server, we require the port address. Okay, so the port address can be ranged from the bit number of bit that can be assigned for the process is 16 bit. So we can say that the size of the port address is 16 bit. That's why the value of the port address can be ranged from 0 to 65535. Okay. So from them, they have already divided into the three categories, in which they have said that the first port number, that is from 0 to 1023, they are known as the well-known port numbers, and they are assigned to the various server processes. For example, let's say 80 is assigned to the HTTP, 23 is assigned to the FTP. Okay. So same way, there are some well-known port numbers that can be assigned from the range 0 to 1023. While 1024 to 49151, they are known as the ICANN registered port numbers. So that means we can say that if we want to use these type of port numbers, we need to take the permission from ICANN. While this 49152 to 65535, these are known as the dynamic or private port numbers. So we can say that these are the port numbers that can be used by the operating system at the client side. Okay. For example, let's say on the client side, suppose our laptop पर जरे आपने browser open करिए छे, at that time in the task manager we can see that some process ID is going to be assigned. Okay, or we can say that some port number is going to be assigned. So these are the port numbers that can be ranged from 49152 to 65535, and it is generally assigned by the operating system. Okay, so we have in the operating system, they have inserted one algorithm that can assign one of the IP address from 49152 to 65535. And whenever that application is going to be closed, so for example, જ્યારે આપણે browser બંધ કરીએ, browser માંથી આપણે mail વાળો tab બંધ કરી દઈએ. Okay, so at that time, that port numbers is going to be released. Okay, and then after that, port numbers can be assigned to some another process. Okay, so these are the port numbers that can be used by the client side, and this type of port numbers can be known as the ephemeral port numbers. Okay, so the port numbers that can be used by the client side and it can be assigned by the operating system, these are known as the ephemeral port numbers. Okay, while the port numbers from 0 to 1023, these are known as the universal port numbers. Okay, so so we can say that the IP address can be used to identify the particular host, while the port number can be used to identify the particular process on the particular machine. Okay. To identify the particular process on the particular machine, we are using the socket address. So socket address is nothing but we can say the combination of IP address and port number. Okay. When we are making any client server communication, we need to use the socket address. Okay, so when there is a client server communication, we need to use the socket address, and socket address is, we can say that, combination of IP address and port number. That means it is uniquely identifying the particular process on the particular destination. Okay, for example, we can say that here we have the IP address this one and port number is this one. Okay, so we can say that we can identify the port, we can identify the process having the port number 69 on the IP address 200.23.56.8. Okay. So we can say that using the socket address, we can uniquely identify the particular process on the particular destination. It may possible that on one IP address, the multiple processes are going to be run. So at that time, we require the socket address. The responsibilities of the transport layer is first one is the encapsulation and decapsulation. The encapsulation means adding a header. So that means the transport layer will receive the different messages from the application layer, and then it will add the header to the each and every chunks. Or we can say that for example application layer पर आपकी जे कोई भी process run थी है. For example, let's say our mail we have opened the Gmail. So if Gmail is generating the various types of messages, or we can say that this type of messages are delivered to the transport layer. On the transport layer, they are known as the packets. So for each and every packet, they are adding the header parts. So the process of adding the header part, that is known as the encapsulation. And the receiving side, we have to remove that header and deliver our message to the application layer. So this is known as the decapsulation. Okay. One more responsibility of the transport layer is multiplexing and demultiplexing. So we can say that let's say when multiple processes are sending the data to the same destinations. Okay, when the multiple processes are sending the data to the same destinations, at that time we require the multiplexing. Okay, so that means we can say that same destination માટે જો આપણો data if we are generating the data for the same destination, we can combine into the single packet and then we'll deliver to the destination. So we have seen this example. Let's take that P1, P2, P3. So આપણી ત્રણ process ત્રણ message generate કરે છે. So M1 and M3 is for this server and M2 is for this server. So the multiplexer can combine this packet P1 and P3 into the one segment, while P2 to the other segment. So P1 and P3 will be delivered to the one server, while P2 will be delivered to the this server. This is known as the multiplexing, and this one is the demultiplexing. Okay. Flow control and the transport layer. That also we have seen that the flow control is between the application layer of the sender and the transport layer of the sender. And the second flow control is between the transport layer of the sender and the transport layer of the receiver. Okay. So we can say that it is the push type of delivery. So for example, the application layer पर कहीं पर data हो, that will be delivered to the transport layer at the sending side. In the same way, transport layer at the sending side, if we have some data, that will be delivered to the transport layer at the receiving side. Okay. So at that time, we require the flow control. So that means this thing can be done by the buffer. So one buffer is at the sending side and one buffer at the receiving side. So જ્યારે આપણો buffer empty થાય, at that time we need to inform the sender that now you can send the data. And buffer જ્યારે આપણે full થાય, at that time we need to inform the sender that now you have to stop your transmission. Okay. So we can say that the flow control at the transport layer can be implemented by the buffer. Okay. One more responsibility of the transport layer is error control. So error control means we can say that we need to detect, or we can say that if the sum of the packet is going to be corrupted, so this type of packet should be identified at the receiving side. Okay, suppose packet માં કઈ data change થઈ ગયો, so that type of packet can't be accepted by the receiver. Okay, so at the receiving side we require some mechanism by which we can identify that which of the packet is corrupted. Same way we require the mechanism in which we need to track the lost and discarded packets, and at the sending side we need to track that આપણે જે પેકેટ મોકલ્યા છે એમાંથી કરેક્ટલી કયા રિસીવ થયા છે. તો કરેક્ટલી રિસીવ થયા હોય તો કેવી રીતે ખબર પડે? તો જેનું એકનોલેજમેન્ટ મળી જાય તેના પરથી આપણને ખબર પડે કે these are the packet that is correctly received. Okay, but there are some packets those are lost and those are discarded. Okay, so we require some mechanism at the sending side by which we can identify that which are the packets that are lost and discarded. Okay. Same way at the receiving side, if we require the mechanism that can recognize the duplicate packets. Okay. For example, as the receiver has already received one packet and again it is getting the same copy of the packet, so it should be identified that this one is a duplicate packet and it has to discard. Okay. Same way we require the buffering at the receiving side, in which we can buffer the out of order packets until the missing packets arrive. For example, let's say કે એક પ્રોસેસે 3 પેકેટ જનરેટ કર્યા છે. Okay, so at the receiving side we require some mechanism in which જ્યાં સુધી જે 3 મેસેજ, okay, 3 મેસેજ જ્યાં સુધી રિસીવ ના થાય ત્યાં સુધી આપણે એને એપ્લિકેશન લેયરને સપ્લાય ના કરી શકીએ. Okay, so at the receiving side we require the mechanism that એક જ મેસેજના 3 પેકેટ છે that has not been arrived. Okay, so by that way we can identify at the receiving side. So how we can implement that thing? So for that they have used the sequence number. So sequence number is nothing but we can say that these are one's number that are assigned to the packet, using which we can identify the packet. Okay, so generally we are using the numbering that is start from 0 and it can go from some values. Okay, but we should be careful about the range through which we can go from, let's say, 0 થી પછી લઈને ક્યાં સુધી જવાનું. So for that we should be dependent on the size of this sequence number on the header. Okay, so for example, let's say header માં આપણે sequence number 4 bit નો assign કર્યો છે. Okay, for example, આપણે header માં sequence number ની જે field છે that we have assigned for the 4 bit. Okay, so 4 bit ની assign કરી છે તો આપણી value ક્યાંથી લઈને ક્યાં સુધી જઈ શકે. So let's say કે our the first sequence number is 0000. The last sequence number is 1111. Okay, that means we can say that our sequence number can be reached from 0 to the 15. Okay, so then after we can again repeat the value like a 0 to the next 15. Okay, so at that time we can keep the track of the first 16 packets, and then after we can keep the track of the next 16 packets like that. Okay, so to track the number of packets that can be sent, or આમાંથી આપણે જે પેકેટ મોકલ્યા છે, કે સપોઝ સ્ટેન્ડર્ડ સાઇડ આપણે ટ્રેક કરવું છે કે આમાંથી કયા પેકેટ આપણે મોકલી દીધા છે, કયાનું એક્નોલેજમેન્ટ આવી ગયું છે. Okay, so for that they are using one concept that is known as the sliding window. Okay, so suppose sliding window is nothing but we can say that it is a one type of variable that is keeping track that આપણે જે પેકેટ મોકલ્યા છે એમાંથી કયા કરેક્ટલી રિસીવ થયા છે, કયાનું એક્નોલેજમેન્ટ આવી ગયું છે, like that. Okay, so we can say that here it is a one type of memory that can store up to the 7 different packets. Okay, so here the size of the sliding window is 7, but it is dependent on the various protocols. Okay, but here assume that the size of the sliding window is 7. Okay, so here this blue part indicates that we have sent the packet 0. Okay, so this blue part indicates the packet that we have sent, but we have not received any acknowledgement. Okay, packet sent થઈ ગયા છે but એનું acknowledgement નથી મળ્યું. એવા packet we have indicated by blue. Okay, so packet 0 we have sent, packet 1 we have sent, packet 2 we have sent, packet 3 we have sent. Okay, then suppose 4 પણ sent થયું છે, so 4 is also indicated by blue. Okay, so these things are to understand the sliding window buffering, or if you want to understand the buffering, then we require this concept. Okay, suppose 5th packet આપણો send થઈ ગયું, so it is also blue. 6th packet is also sent and it is also blue. Okay, so when we can say that suppose આપણું packet 0 નું acknowledgement આવી ગયું છે. Okay, so if you have got the acknowledgement for packet 0, then we can say that now your sliding window is moved. પહેલા 0 થી સ્ટાર્ટ થતી હતી, now it is going to be start from the 1. Okay, so 1 2 3 4 5 6 7 like that. Okay, so જેટલાનું એક્નોલેજમેન્ટ આવતું જાય એ પ્રમાણે આપણી સ્લાઇડિંગ વિન્ડો મૂવ થતી જાય. Okay, so let's say if you want to implement that thing, so you can use something like the array, or let's say you can use some data structures like which one is can be better. I think it can be stack or queue. Okay, so stack can be better. Okay, so in the stack you can let's say like you can જે packet આપણા send થયા છે, that all packets you can push into the stack. Okay, so you can push 0, push 1, push 2, push 3. Okay, so જેટલા બી packet આપણા send થતા જાય, that all packet you can push into the stack. Okay, so you can push 4, push 5, push 6. Okay, અને for example suppose આપણું 0 નું acknowledgement આવી ગયું છે, So you can pop those packets from the stack. Okay, so you can pop 0. Suppose one no acknowledgement આવી then pop 1. Okay, so by that way you can perform the, I think Q will be better. Okay, stack will be better, Q will be better. So that you have to decide. Okay, so you can use the such type of data structure when you have to implement such type of things, okay, like the flow control at the transport layer. Okay. Next thing is, okay, so we are stopped at this topic. So that is the connectionless and connection oriented protocol. So at transport layer protocol, like a network layer protocol, can provide two types of services. The first one is the connectionless service, and second one is the connection oriented service. Okay. So what is the meaning of connectionless service? The connectionless service at the transport layer means independency between the packets, while the connection oriented means dependency. Okay, so what is the independency and what is the dependency? So let's understood this thing by one example. So here we have the client process. That means this is the process that is going to be run on the application layer. This is our client transport layer. This is our server transport layer, and this is our server process that is going to be run on the application layer. Okay. So client process has generated some message. For example, client process was we are using some mail. Okay. આપણે કોઈ mail send કરીએ છીએ. So that mail has generated 3 messages. Message 0, message 1, and message 2. Okay. So those messages are delivered to the transport layer. Transport layer will add the header and create 3 different packets: packet 0, packet 1, and packet 2. Okay. Now, what is the meaning of connectionless service? So it is stated that this all 3 packets, 3 packet આપણા એક જ મેસેજના છે. We can say that આપણી એક જ પ્રોસેસના છે. જે 3 પેકેટ છે આપણી એક જ પ્રોસેસના છે, but still they are independent. That means we can say that they can arrive out of order. So for example, પહેલા આપણું પેકેટ 0 આવ્યું છે, તેના પછી આપણું પેકેટ 2 આવે છે, and then after we are reaching the packet 1. So we can say that here at the receiving side we have the out of order delivery of the message. At the receiving side we have the out of order delivery of the message. So for example, let's say કે મેલમાં આપણે જે કંઈ મોકલવાનું છે, so that should be only the sequence. Okay, for example, let's say કે પહેલા we have the 2 મેલમાં જે રીતે આપણે મોકલીએ છીએ, તો પહેલા આપણો 2 છે, એના પછી આપણો સબ્જેક્ટ આવે છે, અને એના પછી આપણો ડેટા આવે છે. ઓકે, જે મેસેજ આપણે મોકલવા માંગીએ છીએ તે આવે છે. ઓકે, તો 2 પછી આપણો જે સબ્જેક્ટ અને અહીંયા છે આપણો ડેટા. ઓકે, બટ અહીંયા શું થાય છે, તો પહેલા 2 આવે છે, પછી આપણો ડેટા આવી જાય છે, અને તેના પછી આપણને સબ્જેક્ટ ખબર પડે છે. That means we can say that we have the out of delivery of the message. So that means the server side, whatever the message that we want to receive, એના જગ્યાએ આપણને કંઈ અલગ જ ટાઈપનો મેસેજ મળી જાય છે. So that is known as the connectionless service, or we can say that independent delivery of the packets. Okay, so like such type of applications, like the when we are sending some mail, we can't use the connectionless service. Okay, but still there are some applications. Okay, out of delivery 30 હોય તો પણ we have some application in which we can use the connectionless service that we will see later. Okay, so we can say that in the connectionless service we don't have any flow control, error control, or the congestion control that can be effectively implemented in a connectionless service. Okay, so that means in the connectionless service we can't have the mechanism by which we can identify that which packet is delivered in the sequence. Okay, આમાંથી કયું પેકેટ કરેક્ટલી ડિલિવર થયું છે સેન્ડરને ખબર નથી પડતી. પહેલી વસ્તુ, there is no flow control mechanism, મતલબ પેકેટ 0 કરેક્ટલી રિસીવ થયું છે કે નહીં, તો એ જાણવા માટે આપણી પાસે કઈ ઓપ્શન નથી. ઓકે, બીજી વસ્તુ છે કે સપોઝ ઓકે ઇન ધી વર્સ્ટ સિચ્યુએશન, સપોઝ અમારું કોઈ પણ એક પેકેટ લોસ થઈ જાય છે, પેકેટ લોસ થઈ જાય છે કે કરપ્ટેડ થઈ જાય છે, તો that things can also not be identified at the receiving side. Okay, so if the packet is lost or packet is corrupted, so that also we cannot identify at the server side. Okay, so no flow control, no error control, or no congestion control can be effectively implemented in a connectionless service. Okay, so we can say that if there is no flow control, there is no error control, no congestion control. Okay, so what is the need of this connectionless service? So still we have some application in which we want to we can use this connection list services. Okay, so we'll see that there is a protocol called UDP that is following that connection list service, and still there are some applications that can use that UDP protocol. Okay, so before that we'll understand about the connection oriented service. Okay? So in case of the connection oriented service, we can say that first we need to establish the connection with the server. Okay, so the first step in the connection oriented service is we need to send some message to the server and got the connection from the server. Okay, so the first step from the connection oriented service is connection open request. Okay, so client process jare suppose server ne kai પણ મોકલવું છે, so the first thing is we need to establish the connection with the server. Okay, so this client process will send this connection open request to the client transport layer. So when the client transport layer will receive the connection open request, it will send the connection established message to the server transport layer. So once the connection is established, then we can send the message to the server transport layer. So the server transport layer also we have the mechanism in which we can have a we can identify that which one is the first message, which one is the second one, and which one is the third one. Okay, so જ્યાં સુધી suppose અહીંયા પેકેટ 0 આવ્યું છે એના પછી પેકેટ 2 આવ્યું છે એના પછી પેકેટ 1 આવ્યું છે, તો જ્યાં સુધી મેસેજ 0 પછી મેસેજ 1 ના આવે ત્યાં સુધી it will hold the message number 2. Okay, so message 0, then it will holding the message 2. એકવાર message 1 આવી જાય, then after it can append the message number 2. Okay, so it can create the complete message and then it can deliver to the server process. Okay, so ekવાર apno data transfer થઈ જાય, then after also we need to go with one more step, that is the connection close request, so in which we need to terminate our connection. So here also we have the connection tear down step. Okay, so we can say that in the connection oriented service we need to go with these 3 steps. There is the connection establishment, then data transfer, and then connection tear down. Okay, so that means everything should be done very perfect way. So પહેલા આપણે connection establish કરવાનો, એના પછી data transfer કરવાનો, એના પછી we need to release our connection. Okay, and also at the connection oriented service we have this some flow control and error control mechanism through which we can identify that આમાંથી આપણે કયો પેકેટ correctly send થયું છે, so that acknowledgement we can get. Also we can find out that which packet is arrived out of order. Okay, so that all type of service, flow control, error control, congestion control, that all type of services are implemented through the connection oriented service. Okay, so still it is the best way to transfer, like in some critical application જ્યારે આપણે mail send કરતા હોય, at that time we should always go with the connection oriented service. But there is one disadvantage of this connection oriented service is more overhead. Okay, that means we can say that suppose આપણે simple normal mail send કરવું હોય, for that also it has to go with the 3 steps. There is the connection establishment, then after data transfer and connection tear down. Okay, while in case of the connection list service, જેવો ડેટા મળ્યો છે એવો આપણે મોકલી દઈએ without worrying that receiver એને accept કરશે કે નહીં. Okay, in case of the connection list service, જેવો ડેટા આપણો એપ્લિકેશન લેયર પરથી આવે છે, transport layer will directly deliver to the server transport layer without worrying that it is ready to receive or not, or whether it is lost or whether it is corrupted. That nothing we have to worry in case of the connection list service. But in case of the connection oriented, we have the every perfect mechanism in which we need to establish the connection, then after we have to transfer the data, and then we have to release our connection. Okay, so we are going to the transport layer protocols. Okay, so up till now on the network layer we have learned about the IP, ICMP, ARP, and IGMP. We don't discuss about the IGMP. That is a protocol that can be used for the multicasting. Okay, so multicasting we are not discussing. Okay, same way on the transport layer we have the 3 protocols, TCP, UDP, and SCTP. So we'll discuss all 3 protocols, TCP, UDP, and SCTP. Okay, so TCP is Transmission Control Protocol, UDP is User Datagram Protocol, okay, and SCTP. So we can say it is a combination of TCP plus UDP, okay. So these three protocols we have to learn on the transport layer. Okay? So UDP is an unreliable connectionless transport layer protocol. Unreliable means we can say there is no guaranteed delivery of your data. Packet મોકલી દીધું છે, but there is no guarantee that it is received by the receiver or not. And second thing, it is the connectionless. That means connectionless. That means there is no dependency upon the packet. The packet can be arrive out of order at the receiving side. Okay, so it is the unreliable as well as the connectionless transport layer protocol, but it is used for its simplicity and efficiency in applications where error control can be provided by the application layer process. Okay, so when we are using the UDP, it is the responsibility of the application layer protocol to provide the flow control or the error control. Okay, so the task of this UDP is simply to send the data without worrying that receiver is ready to receive or not. Okay, so in such type of applications, we can use the UDP, and it is efficient. That means we don't need to deal with the so much overhead. Okay, like in case of the connection oriented, we have the more overhead for the connection establishment and the connection tear down. So such type of overhead can't be implemented through the UDP. Okay, that's why we can say the UDP is a simple and efficient protocol, while TCP is a reliable connection-oriented protocol. Okay, so that can be used in any application where reliability is important. Okay, so connection-oriented, that means it is also the reliable. Okay, so reliable means we have the guaranteed delivery of your data. Okay, so તમે જે પેકેટ મૂકેલું છે એ ત્યાં સુધી પહોંચેલું ના કહેવાય ત્યાં સુધી એનો acknowledgement ના આવી જાય. So that is known as the reliable. Okay. And it is the connection oriented protocol. That means we need to establish the connection and then we need to transfer and then we have to perform the connection release. Okay, so TCP is a reliable connection oriented protocol. And SCTP, so SCTP is a new transport layer protocol that combines the feature of UDP and TCP. Okay, so before starting with TCP and UDP, we need to go with some well-known port numbers. Okay, so these are some well-known port numbers that can be used by some well-known processes. Okay, for example, let's say eco માટે છે port number આપણો 7. Okay, and eco protocol, we can say that eco process can using the all three protocol can use all three protocol UDP, TCP and SCTP. Okay, so eco ત્યારે યુઝ થાય echoes back a receive datagram. Suppose એવી કોઈ એપ્લિકેશન છે કે તમે જે પેકેટ મોકલાવેલું છે એ જ પેકેટને ફરી પાછું તમારે રિસીવ કરવું છે, સેમ પેકેટ, કંઈ પણ ચેન્જ કર્યા વગર. At that time you can go with the echo process. Then we have the discard. એના માટે છે port number 9. It can discard any datagram that is received, and it is also supporting UDP, TCP and SCTP. If you want to know the active users from the server side, then you can use the users process. એના માટે છે port number 11. Daytime, if you want to know the current day and current time, then you can use the daytime server. એના માટે છે protocol છે daytime. Okay, port number SN છે આપણો 13. Quote, if you want to return the quote of the day, then you have the protocol called quote. Port number is 17. Jargon returns the strings of character. Okay, so if you want to if you are input માં તમે character મોકલાવે છે and output માં if you want to get a string, then you can use the jargon protocol. Okay, here we have the FTP. For that port numbers can be either 20 or 21. Okay, why the two port numbers are assigned for FTP, that we will learn on the application layer. FTP has assigned the two port numbers. It can be either go with 20 or it can be go with 21. Telnet terminal protocol, terminal network, એના માટે છે port number 23. SMTP simple mail transfer protocol, port number is 25. DNS domain name server protocol, port number is 53. DHCP dynamic host configuration protocol, port number is 67. TFTP trivial file transfer protocol, Port number is 69. HTTP Hypertext Transfer Protocol. Port number is 80. RPC Remote Procedure Call. Port number is 111. NTP Network Time Protocol. Port number is 123. SNMP Simple Network Management Protocol. So SNMP can be client or it can be server. For SNMP client, we have the port number 162, and for SNMP server, we have the port number 161. So on the application, these are the application layer processes. Okay, FTP, HTTP, SMTP, these all are the application layer processes. So that all processes we will learn on the application layer. Okay, but you should be aware of this port number that will be assigned to the different types of processes. Okay, for example, these are the general knowledge questions that can be asked in any competitive exam. કે DNS માટે port number કયો છે, then FTP માટે port number કયો છે, RPC માટે port number કયો છે, HTTP માટે port number કયો છે. So these are some questions that can be asked in any competitive exams. Okay, so we'll start with the UDP. So we can say that UDP is a connectionless unreliable transport protocol. Connectionless means the every packets can be independent. Okay, we can say there is no dependency among the packets, and unreliable means there is no guaranteed delivery of the data. It will providing the process to process communication instead of host to host communication. Okay, if UDP is so powerless, why would a process want to use it? Okay, so UDP is connectionless and UDP is unreliable. So you can have questions that why would a process want to use it? Okay, so it said that if a process wants to send a small message and does not care much about reliability, it can use UDP. Okay, sending a small message using UDP takes much less interaction between the sender and receiver than using TCP. Okay, so in such type of process, when we have to send only the small message, જ્યારે આપણે કોઈ નાનો message send કરવાનો હોય, at that time we can go with the UDP. Okay, so it is said that when we are talking about the UDP, there is no much interaction between the sender and the receiver. જેવો સેન્ડર પાસે કઈ સ્ટાન્ડર્ડ ટ્રાન્સપોર્ટ લેયર પાસે ડેટા આવે છે તેવો એ રિસીવર ટ્રાન્સપોર્ટ લેયરને મોકલી દે છે, without worrying that receiver is ready to receive or not. Okay, so જ્યારે આપણે small message મોકલવાનો હોય and when the reliability is not much important, at that time we can use the UDP. Okay, so for example, let's say that example we will see later. Okay, before that we will understand the format of the UDP. So the format of this UDP user datagram is we have the 8 bytes for the header. The size of this UDP header is 8 bytes. Okay, with the IP no header હતો, ICMP no header હતો, તેવી આ UDP no header છે, તેની size છે 8 byte ની. અને total size of the UDP can be from 8 to the 65535 bytes. Okay, and one more thing that we should know about the UDP is UDP always comes with IP. Okay? So જ્યારે આપણે UDP થી કંઈ પણ ડેટા મોકલવો હોય, so we cannot directly send our UDP user datagram, but જેવું આપણે ICMP માં જોયેલું કે ICMP થી કંઈ પણ ડેટા મોકલવો હોય, તો ICMP થી આપણું આખું પેકેજ જનરેટ કરીને that thing we have to put into the IP. Okay, so પહેલા IP નું header આવશે, એના પછી ICMP નું header આવે અને પછી ICMP નો ડેટા આવે. Okay, what is the reason? કારણ કે જે IP નો ડેટા છે એમાં આપણે આખું ICMP નું પેકેજ મૂકેલું છે. So same thing is about the UDP. Okay, so that means we cannot directly send the UDP user datagram, but we have to put this UDP user datagram into the IP user datagram. Okay, so IP નો પહેલા header આવશે, એના પછી આપણો UDP નો header આવે, and then after we have the UDP data, અને પછી જો કંઈ બાકી રહેતું હોય તો પછી IP નો data આવે. Okay, that means we can say that IP ના જે data portion માં we have to put this whole UDP user datagram. Okay, so the size of the UDP header can be vary from 8 to the 65535 bytes. Okay, maximum can be 65535 bytes, and we can say that So we have seen કે આપણી IP જે IP નો ડેટાગ્રામ છે, okay, that can be only size like a 65535 નું maximum આપણું પેકેટ આવી શકે. જે આપણું IP પેકેટ છે, that maximum length of the packet can be 65535 bytes. એના કરતા વધી જાય તો આપણે fragmentation કરવું પડે. Okay, so 65535 maximum we can put. That's why in the UDP also we can go with only the maximum size equal to the 65535 bytes. Okay. What should be the header format? So 8 byte no આપણો header છે, that is divided into the 16 bit, 16 bit, 16 bit and 16 bit. Okay, the total આપણા 16 bit, 16 bit, 16 bit, 16 bit. So we can say that we have the 1, 2, 3, 4, 5, 6, 7 and 8 bytes. Okay, so first 2 byte, or we can say that 16 bit can be used to provide the source port number. Okay, the second 16 bit, or we can say that the second 2 byte can be used to provide the destination port number. Then byte number 5 and 6. So byte 1, byte 2, that is for the source port number. Byte 3 and byte 4 is for destination port number. Byte 5, byte 6, that is for the total length. Total length that is equal to this one. Okay, and this one is the checksum. So checksum 1, 2, 3, 4, 5, 6, 7 and 8. 7th and 8th byte that is used to calculate the checksum. Okay, so just take one example. The following is the content of UDP header in hexadecimal format. Okay, so here they have given the UDP header in the hexadecimal format. CB84000D001C001C. Okay. So for one hexadecimal, we know that we require the 4 bit. Okay. So total, how many hexadecimal numbers are there? Okay. So we can say that the first 4 hexadecimal numbers are indicating the source port number. Okay. So we can say that the source port number 16 bit or 2 byte, or we can say the 4 hexadecimal number that will provide you the source port number. Okay. એના પછીના 4 hexadecimal number that will provide you the destination port number. Then after the 4 hexadecimal number, that is for the total length, and the remaining 4 hexadecimal numbers are for the checksum. Okay. So what is our first question? That what is the source port number? So source port number, for that we have the first 4 hexadecimal numbers. Okay. So CB8 and 4. CB8 and 4 that will give you the source port number. Okay. CB84 એને આપણે, this one is in the hexadecimal, એને આપણે જો decimal માં convert કરીએ તો CB84 has equivalent decimal that is equal to the 52100. That's equivalent to the 52100. So we can say that our source port number is 52100. Okay. Then after the second question is what is the destination port number? Okay. So source port number એના પછીના બીજા જે 4 hexadecimal number છે, that is for the destination port number. So 000D. 000D. Okay. So 000D. D માટે આપણો decimal કયું થશે? તો 10, 11, 13. Okay. So destination port number is 13. Okay. So we can say that destination port number is the second 4 hexadecimal digit, that is 000D, and the destination port number is 13. Okay. Total length of the user datagram, that is the 0013. 0013 indicates the total length. You can say that total length is 0013. The total length of the user datagram is 0016. In equivalent decimal થશે આપણું 28 bytes. Okay. What is the length of the data? Okay, so length of the data you can find out. Length of the data is equal to total length minus header length. Okay, the total length આપણને આ question પછી મળી છે, that is the 28 byte. Okay, we know that the total length equal to the 28 byte, and the length of the header is fixed, that is the 8 byte. So 28 bytes minus 8 bytes. So the length of the data is 20 bytes. Length of the data is 20 bytes. Is the packet directed from a client to a server or vice versa? Okay. આ જે પેકેટ છે આપણું ક્લાયન્ટ સર્વર બાજુ જાય છે કે સર્વર થી ક્લાયન્ટ બાજુ આવે છે? હવે એ આપણને કઈ રીતે ખબર પડે? So for that you have to check the destination port number. Okay. ડેસ્ટિનેશન પોર્ટ નંબર જો આપણો 0 થી લઈને 1023 વચ્ચેનો હોય, then we can say that your packet is going from client to the server. Okay? We know that the destination port number છે that can be range from 0 to 1023. Destination બાજુનો આપણા જે પોર્ટ નંબર છે that can only vary from 0 to 1023. Okay? So destination port નંબરમાં જો આપણી વેલ્યુ 0 અને 1023 ની વચ્ચે હશે, then we can say that your packet is going from client to the server. Okay? તો અહીંયા આપણા destination port નંબરની વેલ્યુ છે આપણી 13. So we can say that your packet is going from client to the server. And what is the client process? So client process કઈ રીતે ખબર પડશે? So we know that destination port number is 13. 13 માટે આપણે કયું સર્વર જોઈએ છે? So for the 13 we know that we have the daytime server. So for the 13 we can say that our client process is daytime server. Okay, the client process is daytime. Okay, so by that way you can answer all the questions. Source port number means first 4 hexadecimal number. Destination port number means second 4 hexadecimal number. Total length means the third 4 hexadecimal number, and this last one is for the checksum. Okay, what is the total length of the user datagram? So that is 0016. What is the length of the data? Total length minus header length. Packet is from client to the server, and the client process is daytime. Okay. So this one is the exercise that you can solve at your home. Okay, so again you have given this 16 hexadecimal numbers, 1 2 3 4. Okay, so total 16 hexadecimal numbers are given. First 4 is for the source port number, second is for the destination port number, then the third 4 is for the total length, and the last 4 is for the checksum. Okay, so by that way you can answer all the questions. The last question is, has the header calculated a checksum for this packet? Okay, so checksum ની value કેટલી છે આપણી? તો 0000. Okay, so we can say that the sender has not calculated the checksum. Okay, so checksum માં કઈ value હોય, then we can say that we have calculated the checksum. Okay, but checksum માં આપણી value 0 છે, so that's why we can say that the sender has not calculated any checksum. Okay, next is the UDP services that we'll see in the next lecture. This